Good day. My name is Zandi Nkonzo. I will be taking you through a lesson on measures of central tendency. First, let's go through our overview. From this lesson, I would hope that learners would leave having an understanding of what exactly statistics is. And then moving along from there, I would hope that as it attends to the central tendency, learners would be able to know what exactly is central tendency of the data, and that learners would be able to know what the measures, to know the exact measures of central tendency, what they are, which ones, different ones do we have, and then I'd hope that learners would leave here knowing how to calculate each measure of central tendency. And I'd hope that learners would be able to leave here knowing when to use each measure of central tendency. And I'd hope that learners would be able to leave here knowing how to interpret each measure of central tendency. Now moving along, what is statistics? Now statistics, let's say for instance, you are doing a study. In this example, we are collecting raw data on the number of smartphones within a family. Now statistics is the organization of data. For instance, you enter each house, you count how many smartphones there are, you collect all this data. But this data, as it stands like this, tells you nothing about maybe the majority number of smartphones in each house. It tells you nothing as it stands like this. But if we organize the data and we are able to analyze that data, then that is what we call statistics. So statistics is the analyzing and the organization of raw data. So in this example, we have organized this data into what we call a frequency table. So now this then tells us more than this tells us. We know that in people who have one smartphone in a household, we've got about 5 households of those. People with 2, we've got about 20. People with 3, we've got about 15, and so on. So this organization of data then helps us to learn more from this data than originally in its raw form. That is why statistics is important. Now, as we check into the measure of central tendency, I'd like us to go back to this example. Now, this example, let's say we take all these numbers and we put them on a number line. Now, we're trying to find out which numbers are at the center. So if we were to put them all in a straight line, which numbers are generally at the center of this data? And that is exactly what a central tendency is. It's a single value that attempts to describe the center of the data, the central position, the numbers at the center, generally what is in the middle of the data. Now, we've got 3 kinds of measures of central tendency. We've got the mean. Now, the mean is what in normal life we call average. We calculate that by taking the sum of all these numbers. So let's go back here. We would take the sum of all these numbers, add them together, and then count how many households, how many these numbers are. And then we would divide by the total number of households that we went through. Now, then we have the median. Now, the median is simple. Going back to our example, we would order all this raw data into a number line, and then we would find the middle number. We would order all the data, remember, and then we would find the middle number. And now the easiest of us all is the mode. The mode is the most occurring value. Going back again to our first example, in this example, it's easy to see it. The mode would be 20 because 20 is the highest frequency, which means it's the most occurring number. Now, let's look at another example. In this example, this is also a form of a frequency table. It tells us how many are at each point. This is like a pictorial form of that. So for instance, if we wanted to find the mean, the average, what we call average or mean, we would then have to add every number. But now we see that at 20, we've got 2 instances of 20. At 22, we've got 4 instances, and so on. So in order to get this, we would say 20 times 2 plus 22 times 4, because 20 appears 2 times and 22 appears 4 times. We would add everything according to how many times it appears, and then we would count the number of x's. And as counted here, you can count them, they are 17. And then we would add all those numbers and their frequency and divide that by 17, which is the number of X's, the number of terms, the number of cookies sold. Then we would have the number 28.88 rounded off. Now looking at our median, we know that we've got 17 numbers, which means if we were to divide 17 by 2, we've got 8.5, 8.5. We have 8 complete. So we would have to cross out the first 8 on the left and then the first 8 on the right. So we'd go 1, 2, 3, 4, 5, 6, 7, 8, right? We haven't counted row 26. Then from the left, we go 1, 2, 3, 4, 5, 6, 7, 8. What's left that we haven't counted is this X. Now this X is our median because it's exactly in the middle. On its left, there's 8. On its left, there's 8. And on its right, there's 8. So 26 becomes our median number. We first have to realize that these numbers are ordered in ascending order. So that is the important part about the median. We need to order these numbers first into ascending order in order to find the middle value. Now the mode is easy to see because it's a frequency. Which one has the highest peak? Which one appears the most? It's the number 22. Now going to another example. In this example, we will not be finding the range. Please ignore that. But we will be calculating the mean, the median, and the mode of this data set. So in this example, we've got a data set on 7 games that have been played. In order to find the mean, we must remember that we must add all these numbers together and divide by how many numbers they actually are. How many numbers they actually are? There's 1, 2, 3, 4, 5, 6, 7, as we know from the fact that there's record of 7 games. So we add all the numbers together and we divide by 7, which we get 5. And then we move on to the next one. We're looking for the median. Now in the median, note, we need to order the numbers in ascending order. First step, every time in median, take the numbers and order them in ascending order. Now, after ordering them in ascending order, we must find what? The middle number. We must take the numbers, order them in ascending order. When we order them in ascending order, we find that 1, 3, 4 fall on the left and 6, 7, 8 fall on the right. And the middle number then becomes our 6. So 6 in this case is the median. But this is only an example of one. What happens when the numbers are not 7, which is an odd number, but the numbers are even? So now let's look at an example where the numbers are even. In this example, just to deviate from the past one, this is an example where the median is calculated for even numbers. So in this example, we're given a number, this with 1, 2, 3, 4, 5, 6, 7, 8 terms, which means they are even terms. Now we must take these numbers and order them in ascending order. As you can see at the last row, we have ordered them in ascending order. We've got 3, 8, 14, 18, 38, 43, 47, and 50. Now, what is different here? In this example, we're looking for the one middle number because they were odd. But when they are even terms, you look for the 2 even numbers. The two middle numbers. So now when we look at the 2 even numbers, we know that we would have 1, 2, 3 on this side. And then we would have 1, 2, 3 on this side. So the 2 middle numbers would be 18 and 38. Now, when we find 18 and 38, what do? We add them together. So 18 plus 38. And then we divide by what? 2. We divide by 2 because there are 2 numbers. We divide by 2. This is the same as finding the average of the 2 numbers. And now when we find what is in the average of the 2 numbers, which is the addition, that number, which in this case is 28, that is the number that is called the median. Remember, when the numbers are even, what do? We find the 2 middle numbers, add them together, and divide them by 2. In this instance, we get the number 28, and 28 becomes our median. Now, looking at our last example, we're finding the mode. Now the mode is the most occurring number, or the number with the highest frequency. As we can clearly see, every other number is written once except for 6, which repeats itself. So in this case, the mode becomes 6. Now, an important, very, very important part of this is, when do we use each measure? Each measure. When do we use each measure? Now let's think of the mode. The mode, it says it is the most occurring number, right? This is best used when we're using data that is non-numeric. For instance, gender, we are counting how many males and females there are in a specific room. Now, if we want to find the middle of the center position of that data, it's not easy for us to just say the center is male or the center is female. The center is best described by the one that occurs the most, which is the mode. So remember, the mode is best used when we have non-numeric data, right? And then we come to the mean. Now, the mean is best used when we have what we call outliers. Now, let's go back to our example. For instance, here in this example, all this data is sort of gathered together. But then we've got this a little bit of an extreme, not as extreme as needed, but for this example, it's a bit extreme, it's a bit removed from the rest of the data, right? For instance, this example would work best, maybe, for instance, if we had another X here that was about 100 and we had an X here, that would work best as an outlier. So an outlier is like an extremely low and extremely high value that isn't inconsistent with the pattern of the rest of the data. So if you have that kind of data, it's not advised for you to use the mean, because it will tamper with the mean. Because remember, when we calculate the mean, what do? We add up all the values, and that extremely low or extremely high value will pull the data. So for instance, in this example, if we had 100 here, what would it do? All these numbers are under the number 10, but we would have this one extreme value that is 100 that pulls the data into the 100 and somethings, right? Which is not a proper description of what generally was happening at the center. So outliers are not pull and tamper with the mean. So it's best to not use the mean when there's outliers, but to only use the mean when there is a presence of, when there isn't any outliers. Now, what if we have outliers? Now we have the median, because the median, once it doesn't add things together, doesn't take the sum, it wants the term in the middle. It wants what? The term in the middle. Now, that would be beautiful when there is no outliers, when there is outliers, because we would then just order the data and the outliers would be outside, will be taken out, and we would only take what is in the middle. We would only take what is in the middle. Let's go back and think about it. In this example, let's just say we had 100 here. The 100 would just be disqualified, and the middle would be two numbers. We would have 8, so we'd have to find two middle numbers, which would be this 6 and this 6, right? And then we would have 12, and 12 divided by 2 is what? 6. So we would come back to 6, and the median would still be 6. So it's not affected by the presence of 100. I hope you understand that it is not affected by outliers. I would hope that at the end of this, you think of statistics as a toolbox, and measures of central tendency are just a tool within that toolbox. And then as we move on, you would be adding tools in that toolbox. And it is very important to know when to use each one of the tools. As I've shown, it's important to know when to use each one of the tools so that you use the correct measures, the correct math, the correct formulas for each problem, and have the correct answers. Thank you very much.